Good morning to one and all. Today, let's we discuss about polymer chemistry. In that, there are different subtopics like polymerization, and addition polymerization, condensation polymerization, and more. Let's start with polymer. What is a polymer? Polymer is a macromolecule which is linked with repetitive monomers is called a polymer. Okay, polymer. For example, polyethylene is a polymer, and the monomer units are polyethene. Ethene, not polyethene, ethene. By polymerization, we get polyethylene, not ethylene. CH2 single bond CH2 and repetitive units. By discussing polymerization is the process of making polymer from the respective monomer units is called polymerization. We discussed this mechanism of polyethylene in the addition polymerization, and polymers are classified into four different types. Four different types: the homopolymer, heteropolymer, homochain polymer, and heterochain polymer. Homopolymer is a polymer made with only single type of monomer units, like and heteropolymer is the polymer made with more than two different types of monomer units. And homochain polymer means in homochain polymer the main chain consists only single molecule, like carbon. Homochain. Like carbon. For example, polyethylene it contains, or example, PVC. And heterochain polymer means it contains different atoms in the main chain, like carbon oxygen. Carbon oxygen, carbon oxygen. In the main chain consists two different types of atoms. It is called heterochain polymer. That's it. And polymerization. In the polymerization, there are three different types of polymerizations: addition polymerization, and condensation polymerization, coordination polymerization. Let's discuss addition polymerization. It is also called as chain growth polymerization. Addition polymerization, the monomer units are mostly unsaturated compounds like double bond, triple bond. It contains mostly double bonds and triple bonds. That's it. For example, polyethylene, 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 CH2 single bond CH2 single bond CH2, or we can the mechanism of addition polymerization, it consists of 3 steps: chain initiation, chain propagation, chain termination. Chain initiation, when the monomer units of polyethylene is ethylene, CH2 double bond CH2, monomer unit. When these monomer units are added with phenyl radical, when these monomer units are added with phenyl radical, a big radical is formed. A big radical is formed is called when the monomer unit CH2 double bond CH2, when the monomer unit is added to phenyl radical means C6H5. Phenyl radical, which is formed from the benzyl peroxide, CC. This phenyl radical is formed from the benzyl peroxide. This radical is reacted with monomer unit of polyethylene to form a big free radical. When it reacts with CH2 double bond CH2, a big free radical. This step is called chain initiation step. Then next, propagation. Chain propagation, when this big radical react with another monomer unit of ethylene, polyethylene, and this process repeats until the completion of total monomer units in the container. Let's take it in a container. Then we get C6H5, CH2, CH2, and not only one radical present in it, it contains different n number of radicals. So another big radical, big chain molecule reacts with not chain termination. Now chain termination, when two big molecules like this react with each other, to form our polyethylene, our required polymer, C6H5. This is our required polymer. This is called chain reaction when two of these big free radicals react with each other to form our required polymer is polyethylene. This is the mechanism that involves in addition polymerization, and let's now discuss about condensation polymerization. In before addition polymerization, there is no loss of any byproducts like water, but in this condensation polymerization, the formation of byproducts like water and H2 gas, CO2 and some other small molecules will be lost in the process of making polymers. The mechanism, let's take an example of nylon 66. The monomer units of nylon 66 is adipic acid and hexadimethylamine. The structure of adipic acid is COOH. And hexadimethylamine. When the monomer units are taken in a container and reacted, we get the product like CH2 NH6 and plus the loss of water molecule. N molecules are taking this and N molecules are taken hexadimethylamine. We'll get N minus 1, 2 into N minus 1 H2O molecules. Okay. In this, that's it. Polymerization. Coordinate polymerization. In this polymerization, an extra initiator like catalyst is used to form a polymer. Like the catalyst, Ziegler-Natta, okay. Ziegler-Natta is triethyl aluminum and titanium tetrachloride. Triethyl aluminum or ethyl or any alkyl. Titanium tetrachloride. Catalyst is formed from the transition metals. That's it. By using this catalyst, we can form HDPE materials high density polythene and low density polythene materials. That's it about coordination polymerization. And let's go to the topic thermosetting plastic and thermoplastic. Thermoplastic. Thermosetting plastic. Thermoplastic and thermosetting plastic. In thermoplastic, they can be reused and recycled even after they prepare. If once thermosetting plastic is prepared by using heating or pressure, by using in a process, once they set it into a plastic, they cannot be remolded. But in can be done, cannot be remolded. Can be remolded and cannot be remolded in thermosetting plastic. And the chemical structure or the chemical properties are not changed in thermoplastic. And thermosetting plastic, once they set into the once they set into the plastic, they can the chemical and physical properties are changed. Okay. And they can be reclaimed from waste. They cannot be reclaimed from waste. They have linear structure. They have three-dimensional network. Okay, and they have linear structure and they have three-dimensional. These are held with weak van der Waals forces. Weak van der Waals forces. They are strong. They held with covalent bond. These are flexible. These are rigid. They are flexible, they are rigid. The thermosetting plastic materials are tough and the thermosetting plastic materials are brittle and thermoplastic materials are tough. Okay. Examples: polyethylene and etc. And here examples for thermosetting plastic is bakelite and formaldehyde resin. Not formaldehyde, urea formaldehyde. And these are the properties of thermoplastic and thermosetting plastic. And let's move on to the conduction polymerization. conducting polymers. Conducting polymers are classified into two types, and polymers are classified into two types, which is intrinsic conducting polymers and extrinsic conducting polymers. And intrinsic polymers are classified into two types. Gate conducting polymers and doped conducting polymers. And again, these doped conducting polymers are classified into two types: p doping and n doping. And extrinsic conducting polymers are classified into two types: metal fill conducting polymers and blended conducting polymers. Let's discuss about the intrinsic conducting polymers. Conducting polymers. Intrinsic conducting polymers. These type of polymers have strong extensive conjugate double bonds. Strong extended conjugate double bonds. In presence of that conjugate double bonds, it acts as a intrinsic conducting polymers. Intrinsic conducting polymers. In these polymers, it has extremely strong conjugate system in the polymer, which is responsible for conductance. Okay, and intrinsic conducting polymers are classified into two types, which is conjugate conducting polymers and conjugate conducting polymers. Okay, conjugate conducting polymers. In conjugate conducting polymers, it has conjugate pi electrons, which is responsible for conductance. Like example, CH2 double bond CH, single bond CH2 double bond CH, like this. Conjugate double bond, 1, 2, 3, one after another. Conjugate, it has conjugate double bond. In the presence of conjugate double bond, due to the presence of conjugate double bond, the conductance is increased. And another type is doped conducting polymers. And these doped conducting polymers, the conducting polymers obtained by exposing the polymer to charge transfer agent to form better conductance. In this doped conducting polymer, it is classified into two types: N-type, P-type, and N-type. Let's discuss both types with mechanism. P-type conducting polymer. The P-type conducting polymer, it is done by oxidation process. In this process we use agent Lewis acid agent. And let's take an example. let's take this is an example, and here the Lewis acid is I2CCl4. This bond can be represented as 2 electrons for the either side, and Lewis acid means which accepts the pair of electron. This electron is donated to this, and this electron also is donated to this, and the next structure is where electron move from this place, where electron is given to another atom, the carbon get positive charge, and this electron also given to that, so it will also get positive charge. Okay, sorry, which is unstable because both positive charges are at adjacent carbons, so which is unstable. This, to make it stable, the electrons move from this place to this, and this place to here. When electron moves here, he will get negative charge, and the electron lost here, so we get positive charge. Negative, positive, and negative, positive, and positive negative creates a bond. So same as before, this electron moves here. So this electron moves here. Here, this electron moves here, and we'll get a negative charge, positive and positive, negative, positive, and this positive negative creates a bond. Positive negative creates a bond. A bond, positive. In this, we can see the charge is transferring from one carbon to another carbon, and it moves on. And by the adding this agent, we transfer of charge is taking place in the carbon. Connection. This is the mechanism, and let's discuss about N-type conduction polymers. Conduction polymers. N-type. In N-type conduction polymers, reduction, it is done by the reduction process, and in the agent is Lewis base. Lewis base is which donates the electron pair to the carbon. Okay. Here the Lewis base is okay. This bond is represented with electrons. The Lewis base is donating the electrons to it. So we will get negative charge. Same charges are at adjacent carbon, so it is unstable. To get it stable, the electrons move from this carbon to here, and this carbon to here. Then we will get here positive charge, and here negative charge. And positive charge, negative charge becomes a bond. Positive charge, negative charge becomes a bond. Positive negative bond, positive negative bond. You will get negative. Okay, and this negative, we have to get positive charge here, so that these electrons are donated to this carbon. Negative. So same as like that, we will get negative. So these electrons are donated to this carbon, positive and negative bond, positive and negative bond. In this also the transfer takes place due to the agent, due to the n-type agent, because it is Lewis base. So this is called n-type conduction polymer. And let's discuss about extrinsic conducting polymer. Extrinsic conductive polymer. In extrinsic conductive polymer, an external agent is responsible for making the polymer more conductivity or more conductance. Okay. In this extrinsic conducting polymer, it is classified into two types: metal field conducting polymer and metal blended conducting polymer. Metal field conducting polymer means when external agent like metal powder is added to the polymer to get more conductance, and in metal field and blended in blended conducting polymers, when external agent or external material or ingredient is added to the polymer to get more conductance, is called a blended conducting polymer. Thank you.